Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And then I've written those out for you right there. Now, when we're talking about opposite, adjacent, and hypotenuse, we're referring to sides in the right triangle. And it's a little tricky. The first one is the hypotenuse. That's easy because it's always across from the 90-degree angle. That never changes. It's always the hypotenuse. The adjacent and opposite depend on the angle that you're using. So if I used theta here, opposite of theta is AC. Adjacent to theta is AB. So I can add to my little diagram here, sine theta is opposite over hypotenuse. That's going to be AC over BC. Cosine theta is going to be adjacent over hypotenuse, so that's going to be AB over BC. And finally, tangent is opposite over adjacent, so tan theta is going to be CA over AB. I'm going to write AC over AB. Okay? So far, we're just looking at the ratios. These little fractions are also called ratios. Now let's do some problems. Okay, so here's a basic trigonometry problem. I've replaced the theta with 29 degrees. I've told you that segment AB is 10, and I've listed an x here. So we're trying to find x, which is also AC. So think about your SOH CAH TOA for a minute. Which ratio is going to link these two things together so you can solve for x? Okay, if you pick tangent, you're right. Because from 29, we have the opposite, that's our unknown, and we have our adjacent, which is our known. So now we can write tan 29 equals x over 10. When the variable's up high, you multiply the bottom times the trig function. So this is 10 times tan 29 equals x, which equals... Before you start calculating, let me give you a quick little warning. There are many ways to measure the size of an angle. The one we're all familiar with that we've used forever is degrees. A right angle is 90 degrees, and so on and so forth. There are two other ways, radians and gradients. For these problems to work correctly, if you're using your calculator, it needs to be set to degrees. If you're using the fancy schmancy Texas Instruments calculator, there are, I think, 2 places in that calculator where you need to set your angle measure to degrees. So if you want to make sure you can follow along with this video, you'll need to stop now and go on YouTube and search YouTube, set my TI calculator to degrees. It's very easy, you just have to go through the menus, but that will show you how to do it. If you have trouble with that, just bring your calculator into our next class and we can get you going. Pull out the calculator. 10 times 29 tangent equals 5.54. And we talked in an earlier video about carrying 2 decimals into your calculations. It's kind of essential to get the right numbers, so remember to do that. Okay, now let's take a look at this one. Here's my theta. I put it in a different spot. I'm giving you the same side, AB. That's 83 now, and I'm asking you to find x. So pause the video and write a trigonometric equation using one of the 3, SOH CAH TOA, and write that down. Okay, let's see what you got. So I'm in this angle. I look out. This is opposite of my angle. So I have opposite, and I need hypotenuse. Which function uses opposite and hypotenuse? That would be sine. Sine is opposite over hypotenuse. So now I can write my equation. Sine 61 equals 83 over x. That's the correct equation. Now, if you recall, when the variable's down low, you switch, you know. So the x comes up here, and the sine 61 goes down below. So now I have x equals 83 divided by sine 61. Pull out my calculator. Let's try that. 83 divided by 61 sine gives me 98 or 94.90. 94.90. It's actually 899, so I round that to 90. Okay, after we worked on finding side lengths in right triangles, we used inverse trigonometry to find angles. So this is if you already know two side lengths in your right triangle, you can then use them to find a theta. Okay? So, pause the video and write the correct equation that relates theta to these two sides. Okay, we have, from theta, we have the adjacent side and we have the hypotenuse. So adjacent and hypotenuse is CAH, cosine. So I can write cosine theta equals adjacent 2.1 over hypotenuse 4.3. Now, do you remember what to do next? Okay, we have to change this to an inverse trig equation because the theta is buried in the cosine function. I can't do anything with that right now, but I can write cosine inverse of 2.1 over 4.3 equals theta. So that's how you switch that up. There's a -1 there. It's kind of like the -1 power, but not really. It just means the inverse cosine of this fraction is going to give us theta. Okay, so let me pull out my handy-dandy calculator and do the math. 2.1 divided by 4.3 equals that. Second function, cosine, that gives me 60.77 degrees. And that's our theta. Okay, here's another one. Two sides are given in our right triangle, and here's our theta. Write a correct inverse trig equation that helps you find what theta is. Okay, now let's take a look. We're here in our triangle. We look out. This is opposite of theta, and this is adjacent. So that's tangent. So the first equation to write is tan theta equals opposite 1071 over adjacent 512. Now to get the inverse equation, we change this to tan inverse, and we put the fraction in there, and that's equal to theta. So that's the correct inverse trig equation. Now let's pull out the calculator and solve that. 1071 divided by 512, and then take the second function. No, that didn't work right. Let's try that again. 1071 divided by 512, and then take the second function for tangent, the inverse function. We get 64.45. There you go. Okay, let's do one word problem using trigonometry. This will help you cement your ability to think critically about a situation and use trigonometry to find what they're after. Okay, so let's read this carefully. A tree's shadow makes a 23-degree angle with the ground. If the distance from the tree's base to the top of the shadow is 87 meters, find the tree's height. Now, this is a kind of problem that you could do. You could go out and find a tree that you can't possibly measure the height of, but you could use the shadow, measure an angle, and you could figure out how high that tree is. Okay, so let's go through this a little bit more slowly and mark up my diagram. So what's going on here is the sun is somewhere up here, shining its way through the day, and the shadow is this line, okay? All right, so first thing, what do we know about how trees grow? We need a right angle to use trigonometry, and you can assume that the tree grows at a right angle to the ground. So now you can see we have our right triangle. We have the tree as one leg, we have the distance from the base of the tree to the end of the shadow as another leg, and the hypotenuse is the shadow itself. Okay? So a tree's shadow makes a 23-degree angle with the ground. That's right here. That's the angle that the shadow makes with the ground. So I'm marking up my diagram. If the distance from the tree's base to the top of the shadow is 87 meters, tree's base, top of shadow, 87 meters. Find the tree's height. So that would be here. That's our x. Okay? So now I have a nice diagram. It's all marked up. If you're thinking about trig, you probably already figured out what you can do. Okay, now if you were thinking of the trig function, what did you get? Tangent, right? Because here's my angle, I've got the opposite, that's what I want to find, and I have the adjacent, that's what they're telling me. So now I can write tan 23 equals x over 87 meters. Okay? My variable's up high, so I multiply the lower part of the fraction times the trig function. So I'm going to get 87 times the tangent of 23 equals x. Pull out the calculator. 87 times 23. 87 times 23. Tangent equals 36.93. 36.93 meters. Now a word about word problems. They're all different. So even though I showed you how to go through this one, the next word problem you might see is going to be fairly different. But just have confidence that inside that problem is a right triangle, and inside that triangle is some information you're given and something you need to find using something from SOH CAH TOA. Okay, I hope you enjoyed that trigonometry review. Please let me know in class if you have lingering questions, and I promise you we'll get this figured out. Now that you've watched the video, take a moment to jot down some notes, some questions, or a quick summary of the content. You can also re-watch the portions of the video that were a little bit challenging. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.